minutes.
It's simple. Play the game, answer your prayer, you point out the three people.
After about 70 log in today. What?
I forgot another. Oh, no.
Right, I'm back again. I'm sorry for that interruption. All right. No, it's fine now. We are back again. We can continue. So, can you all see my screen?
Yes, sir.
All right.
Yes.
All right. Thanks. So, let us proceed. Yeah. So we talked about natural numbers and whole numbers, integers, rational numbers, and all those kind of numbers. This was just a revision. So let's proceed to our next slide here. Yeah. So here, now we're coming to surds. You should remember the surds, né? So this is just one example of a surd. So we want to show you how, or just to remind you how we solve this surd. And then if you don't understand, again, please raise your hand so that we can attend to you. So now let's start with this simple surd. Né? So let's start with this example. Let's solve this one. So square root of 8 multiplied by square root of 8. Here, what we see is that when there's no number here, it means the number here is 2. When it's like this, it means there's a 2. So it means now this one is going to be square root of 8 times 8, which gives us square root of 64. So when we press square root of 64, it's going to give us 8. So this is how we solve this. Yes, I see a hand here. Lithogonolo detail. Yes. Yeah, please unmute Lithogonolo and then Lithogonolo, we can't hear you.
Can they please mute their mics? We can't hear you.
Yes. Lithogonolo.
I'm asking if they can please mute their mics.
Pardon?
Oh, I'm a see. I need to have
I was asking if they can mute their mics.
I need to
Yes.
When some God told no, but you must not eat from.
All right, you can just WhatsApp me my inbox because I can't hear you.
I will show you the amount
so that we can proceed. Ne?
Like I think I'm gonna say like cow is blood in it, so you mustn't eat like cow's meat.
No, not cow's meat. That means you mustn't eat food that is like cooked with blood. Like if not cooked well, that's what it means.
It's blood, man, like blood. Like how we meat with blood.
All right.
No, you misinterpreted.
Okay, so let's proceed. Seems like we're losing lithogonolo here. Let me see.
You guys are misinterpreting. Can you please mute, please?
Yes, if you didn't raise your hand, please mute, huh?
iPhone, mute yourself. I was asking if they can please.
All right. Someone said doesn't understand. I should explain again. So what I was saying is that if we have this kind of number here, like we've got root 8 multiplied by root 8. So how do we go about that? We said these numbers here under the square root, this one, this 2, 2. So it means they are the same. So we can multiply these numbers inside. Let me use this one. So it's going to be square root of 8 multiplied by 8. Square root of 8 multiplied by 8, it gives you 8 times 8 gives you square root of 64. And then square root of 64 is going to give us 8. Remember, square root of 64 is a perfect square. Still remember the perfect squares. Okay? Yes, yes. I see paying your surprise is asking if the powers should be the same in order for us to multiply the inside. So the answer is yes, yes. They should be the same. Yes, they should be the same. All right. So let's move on to our second examples. So we can see here on number 2, the powers are the same too. Do you all see? Yes, the powers are all the same. So it's going to be square root of, cube root of 4 times 2. So cube root of 4 times 2 is going to give us what? It's going to give us cube root of 8. And the cube root of 8 is how much? It is equals to 2. Remember, guys, on number 2, the powers are the same here. You can see this 3, 3 here. So we're going to multiply the insides or the numbers under the root. So it's going to be 4 times, 4 times 2, the way I wrote here. And then 4 times 2 is going to give us 8. And then cube root of 8 gives us 2. Is that fine for everyone? Multiply. Yes, I see. What's this one? Sophie is saying when we multiply 2 roots, you put them under 1. Yes, that's what we do. Exactly that. Remember, guys, when we are solving here, we're not supposed to use a calculator. So, but then when we are done solving everything, we can use the calculator just to verify our final answer here. Okay. All right. So thank you. So we can move to the next, to number 3, right? Oh, let me see this question here. So what happens if the powers are different? Okay, we'll do an example that has got different powers. Ne? All right. Oh, you need to record this. I see Yonela Dumani. All right. I'll send you a link so that you can have access to this whole session today, so that you can always refer to it. Ne? Yonela Dumani. Yes. I show you that. Okay. So now we can move on to the next question. If there are no questions, let me see. They say, sir, can I use it as 2 to the power of 3 over 3? Yes. Okay. I see Sbongile Dina has got another way of solving this. Let me just show you again with this method. So let's can be like this. So this is an alternative, guys. From here, Remember, you've got cube root of 4 times. We've got cube root of 8. Cube root of 8, you can write it like this. Cube root of, sorry, this is cube root of 8, right? So it's going to be cube root of 2 to the power of 3 and 3 here. You see, huh? And then this small 3 is going to cancel this small 3. Then the answer will be 2. So you can either do it this way or you can still do it this way. Is that fine? Yeah, I'll send the link to the group. Ne? Yeah, the link I'm talking about, I'll send it to the group. I see Mona Lisa Spillman. I'll send it to the group. Don't worry for that. Yeah, and please don't write on my screen. I see this. Someone is writing in blue on my numbers. Yeah, please don't do that. All right, so we understood number 2. Ne? So now let's go to number 3. Let's go to number 3. So number 3, how do you do that? So it's going to be equals to, we've got 9 plus root 45 divided by 3. So this is going to be 9 plus 45. 45 can be written as what? Can be written as 9 times 5. It's correct, eh? 45 can also be written as 9 times 5. So 9 times 5 gives us 45. Is it fine?
Yes. Yes, sir.
Yes, so divided by, all divided by, sorry, 3. Eh? All right. So now we're proceeding. Okay. Before that, let me see this question here. Oh, okay. No, it's fine. All right. So 9 plus, can you see what we did here? We replaced 45 by 9 times 5. Okay. Oh, I see a question. Yes. The question Leslie Ngube is asking, why do we write it as 9 times 5? So isn't that we must all make sure that all numbers are prime numbers? Yes. Yes, it's correct. Sophie, you see, Sophie just answered your question here. 3 squared times 9. Yes, I was going to do that after. I see, Sophie, what you're talking about. Yes, it's correct. I was going to do that after this step. Ne? All right. So now the next step was going to be equals to 9 plus square root of 9 multiplied by square root of 5. I know there's a quicker way of doing this, but I just want to accommodate everyone to make sure that everyone understands. Divided by 3. All right. So after that, I'm going to be equals to 9 plus, now square root of 9, what does it give us? It gives us 3 root 5. Remember, square root of 9 gives us 3. So that 3 is still multiplied by root 5. Then all divided by 3.
3.
You all understand so far? Let me see this question. So when splitting the sets, okay, let me see this question. They say when splitting the sets, one has to be a perfect square. Yes, yes, that's correct. I see the Samsung A055. Yes, that's correct. Yes, yes, that's correct. So we're writing it in simplified set form. Yes, yes. That's what we are doing. Kuzwayo, I saw that, exactly what we are doing. So we've got 9 plus 3 root 5 over 3. So can you see here, we can take 3 as a common factor here. So 3 as a common factor, it's going to be, let me just do it here. It's going to be 3 into 3 plus root 5. Remember, guys, we're moving from here to come here. We've got 9. You see, the first number is 9. So I'm taking 3 as a common factor because I see 3 at the denominator there. So that they can cancel out. Then divided by 3.
3.
Then this 3. Then this 3. Okay, let me change the pen. This 3 is this 3.
Gonna cancel each other.
Yes, they're going to cancel each other, and then we'll be left with 3 plus root 5, and that will be our final answer. Let me just do that. So this 3, what's happening with it's going to cancel this 3, root 5. This is our final answer. Remember, 3 and root 5 are not like terms. So, yeah. Okay, let me see any question here. Someone is saying, got it. Okay, I see Tabang Joshua raise the hand. Can you please? Yes, you can speak. Huh?
Sir, starting from step 2, I do not understand.
Oh, okay. It's fine. Let me just repeat it. Né? All right. Okay, I see someone saying 3 is a common factor, then divided by that. Square root 9 is 3. That's the 9, go to 3. Say, can you each term eliminate it? Okay, let's do it again. Huh? I see some of you didn't understand. Let me erase. All right, let me erase and start afresh. Oh. All right, so let's start. We said we've got 9 plus root 45 divided by 3. Eh? So the first step is going to be 9 plus square root of 9 times 5, all divided by 3. I think you all understood this part. Eh?
Yes, sir.
Okay.
Yes, sir.
So now, after this, going to be equals to, we're going to separate the square root of 9 times 5. So it's going to be 9 plus square root of 9 multiply by square root of 5. Let me put this in brackets. All divided by 3. Do you all see this?
Yes, sir.
Yes.
Yes.
So 9
Yes, sir.
plus open bracket square root of 9 times square root of 5. So the square root of 9 times square root of 5. Okay. Oh, okay. Yeah. All right. So now from here, it's going to be equals to 9 plus. Okay. 9 plus. Remember that this square root of 9, it gives us 3, right? Yes, square root of 9 gives us 3.
You have to make it.
So it's going to be 3 times square root of 5, or 3 root 5. The root 5 is still the same root 5 here, and then the 3 is the square root of 9. Square root of 9 gives us the square root of 9 gives us 3. All divided by 3. Then it's going to be equals to
3.
This is what we have now. Can you see that we have, let me change the color here. Let me use this one. Can you see that we've got 3 here?
Yes.
And we've got 3 here. And we know that 9 also is divisible by 3. So we can take 3 as a common factor, right? So it's going to be 3 into, if you say 9 divided by 3, what do you get? We get 3. So 3 times 3 would still give us this 9. So 3 times 3 would still give us that 9. Then plus, remember that we took this 3 as a common factor outside. So we're left with root 5. All divided by 3. Yes, we can do the same. I see Simesihle Kuzwayo is asking if we can divide each by 3. I mean, she's asking if we can divide each by the denominator instead. Yes, we can do that. It's another way of solving that. We can do that. So it's 3 into 3 plus root 5 divided by 3. Then this 3 is going to cancel out this 3. So what are we left with? We are only left with 3 plus root 5. So this is our final answer. Yeah, this is still the revision, guys. We're going to get to the difficult ones. Né? So I just want to make sure you still remember this, because now when you get to grade 12, you don't have to. They don't teach you how to do this. Only you just apply all this knowledge. Né? That's why I'm taking the time to do this. Yes, Tebiso, you're saying you have a question. You can unmute and ask. Yes, I see Samsung A055F is saying we have to make it clear that we are splitting the set. When we're splitting the set, one has to be a perfect square because, yeah, yes, okay. So here, né, on the 45, the reason why we chose to make 9 times 5, it says, is because one of the numbers here, see on what we're multiplying with, has to be a perfect square. So remember 45 is the same as 15 times 3. So 15 times 3, 3 and 15, they are not perfect square. That's why we did not use the 15 times 3. That's why we choose the 9 times 5, because 9 is a perfect square. All right, I hope that is clear. All right. Okay. So I think you all understood this. So now we can move on to the number 4 so that I can give you something to do as well. All right. Okay. So we can move on to the 4th one. Eh?
Yes, sir.
Yes.
Yes, okay. So all right, so let's proceed to number 4. Number 4, I don't know who's this who wrote on. Yeah, you should stop writing on my screen, eh? So that we don't clutter my board here. Let me see if I can erase this. Let's, okay. All right, let me erase this. All right, so let's proceed. All right, so with this, it's a difference of 2 squared. You can all see, I see on the charts there are questions. They say, can Sir fix the sound because it is going on and off? I think it's the network. Eh? Kasongo Abigail. I think it's the network, eh? But next time I'll try to fix that. All right. So now we are coming to number 4. So number 4 is a difference of 2 square. How do we know that it's a difference of 2 square? Because this number here is the same as this one, and this one is the same, and then we've got plus and minus there. So this is a difference of 2 square. So with a difference of 2 square, you know what we do? We multiply this with this, and we multiply this with that, and then this one with this, and this one with that. Then we proceed. So that's how we solve the difference of 2 square. All right, so let's see. So now it's going to be 2 times 2. It's going to give us 4. And then 2 times minus root 5 is going to give us minus 2 root 5. And then plus 2 multiplied by root 5 is going to give us positive, sorry. Let me erase this. Yeah, it's going to give us this 2 root 5. And then you should remember, guys, root 5 multiplied by root 5 is going to give us, sorry, negative 5. Can you see the first example here? The root 8 multiplied by root 8, it gives us 8. Can you see here? So same applies here. The root 5 multiplied by root 5 is going to give us 5. Are we all clear on this?
Yes, sir.
Yes, sir.
All right, so we can move on. Here we can see that these are like terms. Okay, this pen is not clear. Let me use this one. Can you see that these are like terms? Minus 2 root 5 plus 2 root 5. They're going to cancel out each other. So you'll be left with 4 minus 5, which will give us minus 1. Are we all clear on this one?
Yes, sir.
Yeah, it's fine.
Yes, sir.
Yes, sir.
All right, so this was a simple one. So let's go to the next one. Let me see. Oh, let me raise the board first. Let me raise the board first. Can we all see this here?
Yes,
Yes, sir.
Yeah, so I want you to try this. Or before we try this, let me just do this. I just want to clarify something again. Just give me 1 minute and then you'll join in again. Just 1 minute and join in again so that we can do these examples. And then after these examples, I've got exercises for you to do. I mean, we have laws of exponents to do as well after doing this exercise. So just want to finish with that and then we start with laws of exponents. So just give me 1 minute and then I'll join in again. All right. Yeah, okay. Just join after 1 minute, okay?
Okay.
Yes, sir.
Okay.
Okay, sir.
Okay, sir.